Welcome back to our webinar series. We are really glad to have all of you here today. So we have started a new webinar season, and our today's topic is connected with the new features review of TestUp version 60. My name is Alina Zharkova. I'm a business development manager, and today I will be moderating the webinar. And next to me is sitting our software engineer and unsupervised webinar speaker, Philip Stumscheiss. Together, we've prepared a fantastic lineup of topics for the fall season, including Halloween edition on model analysis and signal up, shock sensor calibration, and a features review of new TestUp version 60, which we will be discussing today. While we're still waiting for some people to join us, let me tell you a few words about RULA Technologies. RULA is a European vibration control and data acquisition manufacturer. We manufacture not only vibration control and data acquisition systems, but also amplifiers, portable spectrum analyzers, and shock loggers, and different software different purposes for vibration control, for signal analysis, and calibration. RULA offers customized solutions for automotive, aerospace, research, and other industries. With RULA, you get not only tailor-made solutions and versatile equipment, but also agile support 24/7 and flexible warranty terms. What is more, with RULA, you will get a saving from 20 to 50% with our free updates, our free software updates, and free online education. Now let's have a closer look to the technical sides of the webinar. For all your questions, you can use the question box or raise your hand tool. You can also use raise your hand tool if you want to let us know if something goes wrong. For example, you can hear us or see the presentation. And as usual, we encourage you to ask different questions, and I will be monitoring your questions all through the presentation, and we will try to answer them right away. But if the question needs a more extended answer, we will answer it at the end of the webinar session. I hope everything is clear, and without further ado, I can give the floor to our today's speaker, Philip Stumscheiss. Welcome, Philip.
Hello everyone. In today's webinar, we're going to make a review of TestUp version 60. We will discuss an ability to connect RL-C21 and RL-C21M together. We made this feature because of the customer request. Also, we've implemented 5 new analysis graphs. We've implemented waterfall graphs for random and sign random on random test. We've updated report settings. We have a graph input into some kind of table format like Excel or LibreOffice or some kind of like this, and we will discuss some of the new fatigue test features like logging and exporting the resonance work journal. So let's start with the connection between RL-C21 and RL-C21M. In this version, you can connect these devices together. And of course, RL-C21M must be a master device. There is only one requirement for setting up your vibration tests. The minimum sample rate is 5 kilohertz and the maximum sample rate is 108 kilohertz. So the lower limit is set to this value because of the synchronization between the devices, and the upper limit is set to the maximum sample rate of our regular RL-C21 device. So using this device combination, you can expand your channels number and use temperature sensors for your tests. So to do this, you go to our TestUp software, I'll show you an example. We have two controllers here. We go to Configuration tab, open Hardware tab, and we switch to Default. Here we have a list of two devices. The first controller must be a master, so we select our M model. Here we switch to it and select our second controller. After that, we apply the settings. The TestUp will restart now, and we will have our configuration. I think this feature is really important because some of our customers have one or two regular RL-C21 controllers and they want to expand their system, and in that case now they can buy an 8-channel RL-C21M controller, connect all their devices together, and have a larger channel range. Also, you can draw graphs for temperature. And we have a question now.
Yes, and how many RL-C21 and RL-C21M controllers can be connected and can work together?
You can connect 8 controllers together, and for example, you can have 4 regular RL-C21s and 4 RL-C21Ms, but there is only 2 limits. RL-C21M must be a master, and the maximum number of controllers is 8.
Okay, thank you.
So here we go to configuration and check it. Yes, we have our 2 controllers, and here in the channels we see that we have all 12 channels. We have 8 channels on RL-C21M and regular 4 channels on our basic device. So now let's talk a little bit more about the graph updates. And the best test to show you is sine and random on random. Our first topic is analysis graphs. In this version, we've implemented FRF magnitude, FRF phase, cross-spectrum amplitude graph, and it has an ability to create auto-spectrum lines, coherence graph, and cross-plot. All of these graphs are available on vibration tests except calibration module, and sine-based tests have only cross-plot because their spectrum is really one single frequency. So let's go to this test, and to get better results we'll run in demo mode, because we have some resonances imitation filters. And I'll show you an example of setting up this analysis graphs. And before we start, let's go to test settings and discuss some parameters which will influence these graph creations. We go to control here. Our first parameter which will influence these graphs is control algorithm. It's an algorithm of calculating FRF. We have 3 of them now. I've discussed these algorithms many times, and if you're interested more in them, write us. We will send you a paper about these calculation algorithms. But I'll mention that they depend on the noise on the channel and noise on the inputs. So we will leave it by default. After that, we need to go to control. We need to check the sample rate, and here we have resolution lines. These parameters influence the calculation on these graphs, and we need to check the window type. It will be applied to our graphs. So we press OK, and here we have these four graphs: FRF amplitude, phase, cross spectrum amplitude, and coherence here in the frequency section. So for example, we select FRF amplitude, and we need to select the base channel. All other calculations will be based on these channel values, and channel 2, 3, and 4, their parameters will be their calculations are based on the cross spectrums and auto spectrums, and you need to select the base channel here. So let's create FRF amplitude. Also, let's add FRF phase. Sorry, I misclicked. Let's add more graphs. And here in cross spectrum amplitude, you can select a pair of base channel with itself. In that case, you'll have an auto spectrum line. And let's create coherence graph. And now we will start the test. And I need to mention that all these graphs need real-time data, because we don't have some kind of real-time samples to analyze for these graphs. So here you see that our system is starting up. We're starting to get some lines here. And in a few seconds, we will run the test and see the resulting graphs. And let's add a cross plot now. So here you see that coherence takes values from 0 to 1. Cross spectrum amplitude is really similar with our spectrum density graph. Here you see our FRF phase, FRF amplitude, and here you see the cross plot, which shows the comparison with base channel and all other channels. So these graphs are widely used for analysis, and a lot of customers asked for them. And I will show you another interesting feature which can be used here with these graphs. In this version, you can place 4 graphs in single window. You go to this settings. Here you set number to 4. Our first graph will be FRF amplitude. The second one will be cross spectrum. The third one will be FRF phase. And as the fourth one, we will select coherence. Let's create such graph. Wait for the data. And here you see that we have FRF amplitude and phase, which we can see and compare the results. On the right side, we see the cross spectrum, and this window can be detached and placed on the other monitor, and you can compare running your test and other graphs with this FRF data. And another interesting graph feature which is widely used during the sign and random on random and regular random test is called waterfall graphs. It looks like this, and now I'll show you an example. We go back here. Let's stop the test. And for drawing this graph, you need to go to saving the test and enable saving every 10 seconds because this waterfall graph needs to collect the data and is based on the saved data. If you don't have this option ticked, you will see a message. But here we go to create waterfall graph, channel 1. Here we expand the window. Here we see our frequency versus time graph. And here we have two options. We can enable horizontal cross section here, like this. Oh, sorry, I think I have some issues with color, but don't worry. I'm running TestUp on my laptop and I have some problems with my graphic card. We've tested it and I need to reinstall the drivers, so everything is okay. And here we have two cursors. The lower horizontal cursor is used for power spectrum density versus time graph. And using the vertical cursor, you can see we have a power spectrum density versus frequency graph here. We can track and see our power spectrum density in 3 dimensions. We have amplitude, time, and frequency. Here you can change the gradients maximums like this. Also, you can change scaling, get the coordinates here on the graph, and enable tracking. And now I think I'll show you another interesting feature. Right-clicking on the graph, we can export graph to table. We will press it, wait some time. And all the data from the graph will be exported to the table and we will get a graph here. Here you see that all the lines are exported and also we have a graph here. Using this option, you can export the graph data and use it for your reports or some kind of calculations. Also, we will talk a little bit more about our updated fatigue features. Let's switch to fatigue test and create a new one. We will run from 100 Hz to 1000 Hz at 2 G amplitude. In schedule, we'll add our basic search for resonance command. And here select the first one and select all others for response. Also, let's change sweep rate. And now let's run the test. After we will get all the data, I'll show you new features here. They are placed in the resonance work settings. So here we have our resonance table, and now in this version we have two tabs here, and the second one is settings. We have an ability to save our resonance work journal and resonance work log. Here we will enable it, and here we have two options. We can set the update rate of our log. Here we will update it every 5 seconds, and we have a saving resonance work log option. We will save it every 10 seconds. Let's select one single frequency here. And set the work time as 40, set to 100 seconds. Save the settings and let's start. Here we have a manual control and resonance log. Now we are increasing the amplitude. Here you see that here now we have the data about the current resonance work. It's updated automatically. And all the data is saved to the folder which I showed you in the settings. We will check it after the test is complete. So I think let's stop working. Here we have our resonance work log. It's created as we placed it in the folder. We've worked for we have one test run on the second channel, and here you see the stop reason, frequencies, amplitude, error values, number of cycles, and so on. Let's close the settings. And here you can create a report and press show log for the test run. Let's select another frequency. Or for example, let's select two frequencies on the fourth channel. Let's run it again. And here we have two frequencies in the selector. Startup is complete. And here you see we can switch between the frequencies and they are logging to this table and they are logging into the file. Let's stop it again. We'll get a report. So see, here we have our channel 4, two resonances, their frequencies, and all the information about this. So let's close it. And here you can open resonance work log, and using this table as selector, you can watch the information about this. You can create reports. Here, for example, you want to see the log about this. You see it here. And now you want to compare it with these values. We have two tables, and we can compare the data and create reports. And This feature is widely used with our automotive partners. They ask for it, and it's really good for logging and checking all the data at real time. And now for the most interesting feature. Now we've added some more options in report creation. So we're going to settings. And here, if you don't have a short report, in the graph section, we have a list of all the graphs which can be created in our software. And now you can add your custom settings to them. For example, you enable it, you can set the channels, change their color, change their lines, and also if you want, you can create a graph for selected channels. For example, this way there'll be created 4 graphs for channel 1, for channel 2, 3, and 4. And it can be used when you have a large system with a lot of channels which are grouped. You can enable this feature, and using it, you can create a report, and after that compare this data, print it, and so on. It is a really important feature, and I want to say that in the next release, or maybe the version 64, we will get a new report tool, and these features will be more extended. So I think I showed you all the most interesting features of this option. If you want to test them, get a version on our website. If you have any questions, write us emails. I think we will get more educational videos soon. And here I want to make a conclusion that using our regular RL-C21 and RL-C21M together, you can cover all your needs during vibration tests. Analysis graphs are really good for checking channels correlation and their cross influence, and I think it's really important while testing big objects or some kind of lone objects. Waterfall graphs are used for three-dimensional spectrum analysis, and we've also made a lot of useful tools and graphs in this release which can help you during your vibration tests. So, do we have any questions?
Yes, we have an interesting question. The controllers have different temperature ranges. Does it influence on getting temperature data during the tests?
I think no, because regularly the controllers won't run at their temperature limits, and that's only the informational data. For example, every PC has its temperature ranges it can work with, but you'll really rarely have a situation when you need to run your PC at 60 degrees Celsius. So I think it won't influence the results because, for example, if you have a climatic chamber and have some temperature sensors connected to RL-C21M, your controllers will be placed outside this chamber, and you'll only get the data, so it won't influence the results.
Okay, great, good to know. So I think we will have a few minutes waiting for some questions, and then we will be ending the webinar. We do have a question. Can you hear me? So can be used with the TMS Smart Shaker?
I'll say that we work with, I think, all kinds of shakers because I have an open software. Here we have a shaker database, and you can add your shakers to it and run the tests with your shaker, but you must remember that in some passports the displacement limits are set as peak to peak, but in our software we set them as zero peak. It's mentioned in the manual and it's really important. We have a video on our channel for shaker settings setup. If you're interested with compatibility with your shaker, watch it or write us an email, but I think you won't have any issues with this shaker.
Yeah, agree. And I also can see that Yossi used raised your hand tool. Do you have any question? So I think we will be closing our question section, and if you have any questions or if you will come across any question after the webinar, please ask these questions at our emails. You can use contact@rulatech.com or use my email address manager@rulatech.com. Thank you for being with us today.